So when we're solving a system of equations, while a graphical approach may best illustrate why a solution must be an ordered pair, it does have an obvious drawback, which is non-integer solutions are difficult to spot. For example, if our solution was x is equal to 2/5 and y is equal to 12/5, and this was a solution to a particular system, this would be difficult to pinpoint as a precise location on a hand-drawn graph. So to overcome this limitation, let's consider a method known as substitution. Now, it doesn't mean that every time we use substitution, our solutions are going to be fractions. Rather, that there is an alternative to finding a solution to a system where we don't have to use graphing. So let's consider this system. X equals 4y plus 7 and 2x minus 6y equals 12. Now, what we're going to do is we're going to convert our system into a single equation with one variable by substituting for x 4y plus 7. Since x is equal to 4y plus 7, we're going to put that into the second equation. So the second equation, I'm going to write 2 and then parentheses where x was. And inside of parentheses, I'm putting 4y plus 7. And then I continue on with the equation. Minus 6y equals 12. Now I have an equation that has one variable. Now I'm going to solve for this variable y, starting with distributing the 2 to the 4y plus 7. So that gives me 8y plus 14, and then minus 6y equals 12. Okay, let's combine like terms. The 8y and then the minus 6y gives us 2y, and then plus 14 equals 12. All right, let's subtract 14 on each side. So that gives me 2y equal to negative 2. And now we're going to divide by 2 on each side. So we get y is equal to negative 1. Now, once you have y, you can back substitute y equal to negative 1 into either one of the original equations. I'm going to choose the first one, x equal to 4y plus 7, because I just think it's easier to use that one. And so I'm going to write x is equal to 4 and a parentheses for the y since we're substituting negative 1, and then plus 7. So simplify, we get x is equal to negative 4 plus 7, which is positive 3. So our ordered pair for this example is 3, negative 1. Now, if this were a graph, we would know that the graph would have intersecting lines at this point, 3, negative 1. All right, let's see another example. This time we have the system 5x plus 3y equals 28 and x minus 3y equals 2. Now, this particular system was not as kind to us. We don't have one equation where we're already solved for a variable, but that's okay. If you look at the second equation, it's actually quite easy to solve that particular equation for x. And so that's what I'm going to do. I'm going to solve this particular equation for x by adding 3y to the left side and then adding 3y to the right side. So that's going to give me x equals 2 plus 3y. All right, this is perfect because now I can use this information to substitute. And I'm going to substitute for x in the first equation. So I'm going to write 5 and then parenthesis where x was. And in the parentheses, I'm putting the 2 plus 3y. And then we get outside of parentheses plus 3y equals 28. All right, now we can continue to solve for y. So I'm going to distribute the 5. To the 2 and to the 3y, and that gives me 10 plus 15y plus 3y equals 28. Combine like terms. So that gives me 10 plus 18y equals 28. Subtract 10 on each side. That's going to give me 18y equals 18. And then divide both sides by 18. And we get y is equal to 1. All right, and then as before, you can substitute the 1 into one of the original equations. I'm actually going to use the x equal to 2 plus 3y because it's easier. So we have x is equal to 2 plus 3 times 1. So x is equal to 2 plus 3, which equals 5. So we have one solution, and that ordered pair is 5, comma 1. All right, let's take a look at another example. All right, we have an example here, negative 2x plus 5y equals negative 3. And the second equation, negative 3x plus y equals negative 11. So go ahead and try this example on your own and pause the video, and then we'll do it together. All right, so you see here for the second equation, although we don't have an equation where it's equal to x or equal to y, we can see in the second equation, it's fairly simple to solve for the variable y. So what I'm going to do here is I'm going to add 3x to both sides. And so I get y is equal to negative 11 plus 3x. And that is what I am going to use to substitute. All right, so I'm going to substitute that into the first equation. So I'm going to write the negative 2x plus 5 parentheses negative 11 plus 3x equals negative 3. Okay, now continue to solve for x. We're going to distribute the 5 to the negative 11 and to the 3x. So that gives me negative 2x minus 55 plus 15x equals negative 3. All right, combine your like terms. So that gives me 13x minus 55 equals negative 3. Add 55 to both sides. So that gives us 13x equals 52. All right. Divide both sides by 13. So we get x is equal to 4. All right, now I'm going to substitute 4. You can use any one of the original equations, or I like to use the y equals negative 11 plus 3x because it's easy to finish solving for y. So we have y equals negative 11 plus 3 times 4. So that gives us y equals negative 11 plus 12. Y equals 1. So our order pair is 4, 1. Got a lot of 1s for y. Okay. So here's a question that we did previously using graphing. And the equations are y equals negative x plus 1 and y equals negative 2x minus 3. And they are already graphed here, which we did in our previous lesson. And the solution is negative 4, 5, as listed there. Now, this particular system, although it's fairly easy to solve the system using graphing, but it's just as easy to solve the system using substitution. So I am going to do this again to show you if both of these equations are equal to y, which basically means we can set them equal to each other. So we have negative x plus 1, that's this part, equal to negative 2x minus 3. And we can set them equal to each other because they're both equal to y. And now we can solve for x. So I'm going to add 2x to each side. So that gives me 1x plus 1 equals negative 3. And then I'm going to subtract 1 on each side. So that gives me x equals negative 4. All right, to get the y value, we can substitute into either one of these equations. So I'm going to use the second one, the y equal to negative 2x minus 3. So we have y is equal to negative 2 times negative 4 minus 3. So y is equal to 8 minus 3, which gives us 5. So as you can see here, we get the same answer as we did previously. X is negative 4, comma, y is 5.